Hey everyone, it's Mrs. Olson. We are starting lesson 4, which is the function operations and also composition of functions. On your notes here, it says 6.3a. So this is section 3 of chapter 6 in your textbook. So if you want to look there, you can always look there for more information. All right, let's go ahead and get started. So we're going to do operations, and that's addition, subtraction, multiplying and dividing with functions. And those examples there in the box. Let's do some with f of x here and g of x here. We are going to subtract. All right, so when you do this, and I'm going to use some colors here just so that we can see what we're doing. And I'm subtracting g of x, which is x minus 2. If you're subtracting, remember to put parentheses around that function. You are subtracting all of it. And then you can go ahead and distribute that negative through. So we have x squared plus 3 minus x, now plus 2. Here are my like terms, so I will combine those and I'll put that minus x here, so that's in descending order, and now the plus 5. So just like you would, with other addition, subtraction of other things, but you can do it with functions. We're going to multiply two functions. So we have f of x, which is x squared plus 3. And again, I'm going to use parentheses here. And then the x minus 2. And you'll recognize that this looks like two binomials. So you can FOIL or distribute here. And then I'll do the 3. Just like that. And then again, you'd want to make sure it's in descending order and your like terms are combined, and we've done that. And so that's that. Now, let's do this with some new stuff here. For this unit and last unit, we learned about properties of exponents, and we've also recently learned about rational exponents. So we're going to combine that with this as well. So let's see, we have f of x here. I'm just going to highlight these again just so I can see what I'm working with. And here's g of x, and I'm supposed to add g of x to f of x. And I'm going to do this in the order that it's telling me just to be safe. So g of x first, 5x to the 1/3, and 4x to the 1/2. And I'm going to add to that f of x. This is a negative 3x to the 1/3. So when adding for like terms, remember that you have to have the same base and the same exponent. So my like terms have to have the same base and the same exponent. So this one that is raised to the 1/3, I can add it with that term. And then I can also, this one with the 1/2 as the exponent, I can add those two terms. All right, so here these will be 2x to the 1/3. And then the next term, the 4x, that'll be 8x to the 1/2. Again, you just add that coefficient. The base and the exponent don't change when you're adding and subtracting like terms. You just add or subtract that coefficient. All right, the next one, again, subtracting here, so I'm going to be very careful. And I also want to make sure I put it in the correct order. So we're going to do g of x first. And then we're going to subtract from that this term. So I am going to stop here and let you finish. And then in the next video, you can check your answer and see if you got it correct. Moving on. Now let's do some multiplying and dividing with functions that have these rational exponents. So let's see, I have f of x here. That is 4x to the 2/3, and I'm going to multiply that to g of x, 5x to the 1/2. So let's go over what our rules are here. So this is 4 different things really being multiplied. We've got this number, this variable raised to a power, another number, and another variable. So we can multiply the 2 numbers together, but remember what we do. We add the exponents if the bases are the same. That's the product rule. If we have a product here with the bases the same, we add the exponents. So 4 times 5 is 20. And now I need to add 2/3 to 1/2. And I know you all love fractions, right? So in order to add fractions, we need common denominators. So off to the side here, let's see, 6 would be a common denominator, and 2/3 would become 4/6, then 1/2 would become 3/6. So it looks like we have 7/6. So that would be my answer there. Let's divide and go over again how those rules of properties of exponents apply here. So we have f of x being divided by g of x. So 4/5 doesn't really simplify. I'm just going to go ahead and keep that as 4/5. For the exponents, again, the bases are the same, so I would subtract these exponents and their fractions. So again, I want common denominators. So I'm going to subtract 1/2 from 2/3, which would also be 4/6 minus 3/6, or 1/6 altogether. And when you subtract the exponents, your answers go in the numerator first. If it happens to be negative, then in the next step, you can move it to the denominator. But for now, that is where it goes. All right, so now we're going to do composition of functions. And I don't, a way to explain this is that you're taking one function and you're using it as the input into the other function. So not just a number, but you're taking the whole function and you're inputting that in for the x into the other equation. There's a couple ways that this can be written to do a composite function. This is pretty typical here. And the way that you say this is f of g of x. Another way that it can be written, we don't do this as much in this class, but with this dot in between the two functions, and you'd still say f of g of x here. And there is a note here that this f of g of x, the result that you get from doing that is not necessarily the same as g of f of x. They can and most likely will be different. All right, so I have 3 different functions we're going to practice this with. Again, I'm going to just highlight these here so that I can kind of notice which one is which while we're doing the problems. And so the first one, f of g of 3. So you start on the inside and you work your way out. So what we're going to do here is this means that I am going to plug in for x 3 into the g function, the g of x function. So for g of x, actually, let me go back to using that color for g. So we're going to do g of 3 first, and I'm going to plug 3 in. Now, careful here, it is just the 3 that's being squared. And 3 squared is 9, and then we're taking the opposite of that. So g of 3 is -9. Now we take our result and plug it into the f function. So I'm going to take that result I got and plug it in for x. And 3, so right here is where the x is. I'm going to plug in that -9. And I get -25, it looks like. So we did that with a number because it's a little bit easier to see what to do with a number, but now let's just do it with the functions themselves. So here I'm going to be taking g of x and plugging that in, that whole entire function, which is the -x squared. I'm going to plug that in for my x in the f function. So it looks like this. This is what I'm plugging in into the f function. And look up there, and I have a 3, and then instead of an x, I'm going to write the negative x squared plus 2. So again, this function right here, the g of x function, what that is equal to was plugged in for x into the other function. And now I'll simplify. This will be negative 3x squared plus 2, and there isn't anything else for me to do there, and that is that. Let's do one more because I know these are a little tricky. F of x, this time we're going to take f of x. Here's f of x, and we are going to plug that in for x in h of x over here. So everything that I see for f of x, the 3x plus 2, is going to be plugged in for h of x right there. Okay, so now for x, I'm going to put in 3x plus 2. That was my x right there. I just plug that in, and now I'm going to continue with it with the minus 2 divided by 5. I can do some simplifying here. This plus 2 and minus 2 will cancel, and I have 3x over 5. All right, we're going to do a couple more, and then you can do the rest on your own, and I'll have a second video for you to finish it up. All right, so here's our functions. We have f of x and g of x, and we have h of x again. This time we're going to do like the first example and plug in the numbers. So for g of x, I'm going to first do g of negative 4, and that will be negative 4 squared. So notice that there's two different negatives. There was the negative that's part of my x, and then there's the negative that was out in front that's separate. And negative 4 squared is 16, but I still have that negative out in front, making it negative 16. Now that's going to get plugged in to f of x. So f of negative 16. And look at our function up here. 3, plug in the x, like that. Negative 48. I didn't really need a parenthesis down here. There we go. And we get negative 46. All right, so in the next video, I'll finish off 11 and 12, and you can check there.